Hello, welcome back to Computer Science AP. In this unit, we're studying arrays a little more deeply and a little more carefully than we have in the past. I really want to have our focus be on the types of problems that you would encounter on an AP free response question about arrays. These questions can be very challenging, and they really require you to take your time to read the problem and think about what it's asking you to do. Now, this problem here is one I've made up, but I think it's maybe similar in the kind of style to what you might find. Maybe a little silly and probably not perfect, but they're a little better at writing these problems than me. But let's take it apart, see if we can understand what it's asking us to do, and then maybe write some of the code. So the following class contains details about a house in the public class house. Okay, so this is the way these problems usually look. They'll give you a class, and you'll see this line here a lot. It'll say fields, constructors, and other methods not shown. So this is not a complete class that you should be trying to make work. This is a class where they're showing you only the information that you need, okay? So we can see that we have a method, all right? And this method returns the distance of a house from the nearest fire hydrant. So this returns the distance of a house from the nearest fire hydrant. And you can see it says at return. Well, that's what we call an annotation. It's meaning that it's returning something, and it gives a description of what it is. These are called Javadoc comments that you should be familiar with. This is the distance from the nearest hydrant. All right, so let's take a look at this method and see if we can, what we can understand about it. First of all, you'll notice it says implementation not shown. There's basically two kinds of methods that you'll see in a class on the AP free response. Either it'll say implemented in exercise blank, meaning you're going to implement it, or you'll see implementation not shown, which means they're not bothering you with showing you the code, or perhaps they feel like it might give you answers, but they're just telling you that you should assume this method works fine, but you don't need to know the code for how it did. Most code editors allow you to hide the method body, to kind of scrunch your code together, so you can think of it like that. So we just know that it works. Calling this method returns the distance of a house. Well, what house? Notice that this method is not static. That's the next thing I want to point out. It's not static, which means it has to be called on an instance of the house class. That instance could be in an array list, or it could be a variable that references a house that was constructed. Okay, since we don't have the constructor, I doubt we'll be making our own house instances. We'll probably have to work with someone else's. But if we have a house called maybe H, we would get its distance from the hydrant by simply saying H dot get distance from hydrant, if we're in a class outside of house. If you're in the house class and we're working, then we would call get distance from hydrant by simply saying the method get distance from hydrant. So remember that difference. If you're in the class, you call an instance method by just saying the name of the method. Same if you're calling the method of any superclass that your class is subclassing. If you are not in a class or a subclass of that method that has that method, you have to call it on an instance. All right, we have another method. This returns a number of stories. So public int get number of stories. Again, it's not static, so it has to be called on an instance. If it were a static method, we would call the name of the class like house dot get number of stories. But this is instant. Finally, we have a string. This goes get name of owner, and this is again not shown, but this returns a string containing the owner's last name. All right, the following class contains fields and methods describing a street with houses. The addresses of the houses correspond to the positions in an array lots. If a house is not present at a specific index, the value at that index in lots is left null. So we have an array, and we're going to have house instances in that array. If there's no house, like a vacant lot on that street, then that index will be null. So let's take a look at what that might look like in the memory. So in our last session about arrays, we talked about integer arrays, but now we're talking about object arrays. So an array, we can think of the memory of the computer as like just a big stick of memory, okay? And I know these lines aren't very straight. We're going to deal with it. So each one of these little places in the memory can hold information. Lots is the street information, and it is an array of houses, okay? So let's take a look at lots. Lots is an array of houses. So what does lots do? Well, it points somewhere. Now, we didn't make this array. They made it for us, okay? Sometimes you have to make your own. Sometimes they made it for you. So somewhere in the memory, there's an array. How long? I don't know. However many streets are on that. However many streets or houses are on that street, or how many. How long the street is, possibly, right? I'm going to add just one more just so we can see. Okay. So there we go. Now, how do we know how many streets are in that? Well, the number of them, this would be 1, 2, 3, 4, 5, would be in something called lots.length. And it's a variable, a public variable. This is the case here, the way I've drawn it would be 5. All right, so what's stored at each one of these places? When we were dealing with an array of ints, each one of these had a binary representation of a number. But that's not the case here, because these are storing houses. And a house is a reference type. So lots is a reference. It has instructions on where to find the start of this array in the memory. Then each one of these places in the array, for example, this is lots bracket 0, right? Well, that contains not a house, but a reference, so a pointer to some other place. Maybe in some place down the line, right? Another place where there's a house, maybe. But in fact, objects are stored a lot more complicated than that, because parts of the house, like the name, can be stored one place, another place, another. So it gets really difficult to start talking about how a complex object like a house is stored. So we're just going to call it's somewhere in the object heap, just out there somewhere in the memory, and we can call it by saying lots bracket 0. And maybe this is pointing to some other house right over there. And maybe this one here is also pointing to another house somewhere else. But let's say that this one was an empty lot on the street. Well, that's supposed to be left null. And if I try and do something like get the name of the house owner and it's null, it doesn't reference anything. So I would get what's called a null pointer exception. And they're testing us to make sure that we avoid that. So we don't ever want to call a method on an object that's null. So that would be very, very bad. All right, let's go back to the problem. So we know we have this lots array we're going to have to use. And once again, we said other private fields, methods, constructors not shown. Okay. Returns the index in the array, that is the address of the house whose owner has a name equal to the name. So we're going to be returning their position in the array. The addresses on the house correspond to positions in the array. So this is where we're going to find their position based on the name of the owner. So we'll be implementing that in exercise 1. So we really want to make sure we understand it. So the find house method is going to find the index in the array that has a house whose owner's name is equal to that name. How will we get the owner's name? Well, remember, in the house class, we didn't have to do any work, but we have to use these. We have get distance from fire hydrant, get number of stories, and get name of owner. So we'll have to use that. And you want to keep referencing back to those. Okay, let's go ahead and do that right now. So I'm just going to write this in BlueJ as a code editor. I'm not worried about it being perfectly right, though. So public int find house, right? This is called, I think, street. And I am going to go ahead and just say, right, it was called street, right? Oh, it's street info. My bad. Public class. I'll just say street. So, all right. In order for me to make this work, though, I need to have something called house. Okay. And I'll just leave it like that. All right. So we're going to say public. We're going to say private. Array of type house lots. And we have public int, and it was called find house. So if you were working this on the actual AP exam, again, do not sit there and try and write a house class. That class is already written. I just did it so I didn't get a ton of errors right now while I demonstrate how I would solve this problem. And I'm also not going to go in and write the method get owner's name. So get name of owner. We're not even going to write that because I want to emphasize that we're not supposed to write the house class. So we need to find the index of the house where the owner's name is equal to name. So we're going to start looping through the array. So we'll say for int I equals 0, I less than lots dot length, because the length of an array is equal to one more than the last index, because the indices start at 0, and then I plus plus. So I'll go through each index one at a time. All right, so I need to simply ask if the name of the owner at that house is equal to this name. But I want to avoid accidentally calling get name. Remember, get name of owner. I don't want to call that on null. So I can say if lots bracket I does not equal null, then I can say if lots, I could say something like house H equals lots bracket I. Then I can say if h dot get name of owner dot equals name. So when you are asking if two objects are equal to each other, you have to use dot equals. It's give me an error because we didn't write that code, and I don't want to waste time writing that method. But I want to point out you cannot use equals equals to compare two objects ever, and a string is an object. You can only use equals equals for booleans or ints, and kind of for doubles, but not really. But never for objects. Never for reference types. So if we do find that, if we find a house H and the name of the owner is right, well, then we can return I. But what do we do if the house does not match the name of the owner? Well, the answer is we do nothing, because we need to let it keep searching. A lot of people will say something like return false, or they'll want to do something there. No, you don't have to put an else if you have an if. You don't have to have an else just because you have an if. We're just I equals 0. Does that house match the name of the owner? Yes or no? If it does, great. Return I, the index that we're at right now. If it doesn't, let the loop continue to increase I. When we are all done with this loop, the instructions say that we are supposed to return -1 if a home with name as owner is not found. So one of the worst things you can do on the AP exam is early return. If you're supposed to search an array for something, you better not return -1 until you have searched the entire array. So yes, I can return I as soon as I find it, which stops the loop and it won't go any further. But if I didn't find it with the first house, don't return -1 then. Wait till it completes the loop. All right, well, could we make this code any shorter? Well, yes, we can, because I can actually call get name of owner directly on lots bracket I. So I could just simply take that and put it there, and then I don't need that. And then lastly, I can actually use what's called the short circuit nature of and that's a principle that you really need to know for the AP exam. The short circuit nature of and says that we don't want to call get name of owner if this is null. If this is null, this is going to cause an exception. But because false and anything is false, let's say lots bracket I equal null. If lots bracket I equal null, then this statement would be false. And Java would see the and say, well, false and anything is false, so I won't check it. And it will avoid calling this exception. So a little bit of an advanced topic, but you don't need to write your code that way, but you need to understand it. So because they definitely will do that. They'll ask you to use the short circuit nature. So remember, if false and anything is false, so if the first thing is false, Java skips the second. We use that to our advantage so that if lots were null, it would not actually try this, so it wouldn't get the null pointer exception, which shuts down the program. And the other short circuit nature is or. True or anything is true or anything is true. So if you have an or statement and the first part is true, it won't evaluate the second. All right, let's go on to the next one. All right, the next thing we need to do is we need to return whether this street has an average safety based on the average distance from the hydrant to a house on the street is less than 50 meters. So what we're simply going to do is we're going to add up all the distances from a house to a hydrant. And if it averages less than 50, then we will we'll return that it's safe. Okay, so let's do that. First of all, let's take a look at what was returned. When we have get distance from hydrant, it's an int. And we need to remember that if we try and divide an int by an int, we will get integer division. So if you had something like 8 divided by 7, you would get 1. And if you had 7 divided by 8, you'd actually get 0. So we want to be careful about that. So we're going to watch how we handle that. So we're writing average safe. We're going to return true if the average house is safe. So public Boolean. I'm going to go ahead and delete this one, by the way, because I don't want these errors piling up on me. So public Boolean, average safe. And so the goal is to loop through the lots and get the distances and divide by how many there are. So I'm going to make a couple temporary variables. First of all, I'm going to make an int called num houses. And I'll start at 0. Then I'll make another variable double called distances, and I'll start it at 0.0. And I had to make one of them a double, and by doing that, I'll avoid integer division. Remember, we're going to find the average distance that the house is from a fire hydrant, so we want to add them all up and divide by how many houses there are. But the number of houses does not equal lots.length, because some of them are null. So let's loop through our lots. For int I equals 0, I less than lots dot length I plus plus. If lots bracket I, the ith house on the lot, does not equal null, then we can do something. We can say distance plus equals lots bracket I, that's the house that we're on, dot. And now let's review. Let's go back and see what was the name of the method we're supposed to use in the house class. We're supposed to do get distance from hydrant. I'll just borrow it. Oh, that did not work. I'll just type it out. Get distance. Ooh. Get distance from hydrant. All right, and we're going to add all those up. Well, I'm not done with it. I need to do another one, though. All right, so let's do, if we found the house, we also need to increase the number of houses. So I'll do houses plus plus. So that added the distance and houses plus plus. All right, so now let's talk about what we could do. Let's see, distance. All right, we could say this. If distance divided by the number of houses is we're looking for it to be, according to the instructions, we're looking for it to be less than 50 meters. So less than 50, I'll say 50.0, then we can return true. Then we can say else, return false. So that's why a lot of my students would do this, because we know you're supposed to return true if the average distances was less than 50. Otherwise, return false. But do you realize there's really no reason to do that? Because you're saying if this is true, return true. If it's not true, it's false. So you're saying if it's true, return true. Else, if it's false, return false. Why don't you just return that value? Return distance divided by num houses less than 50.0. This will evaluate to either true or false and return it. So that's kind of a faster way to do that, but both are acceptable, whatever makes sense to you. All right, next we get to write the method very safe. This returns whether the street is very safe based on no house having a distance of less than 50. These are some serious typos. This should say returns whether this street is very safe based on no house having a distance of more than 50 meters. So return true if no house is greater than 50 meters from the hydrant. Okay, so that's it. So in this case, no house is greater than 50. I think that means that we're allowed to be exactly 50. So we'll write that method. Public Boolean very safe? Very safe, just very safe. So in this case, you have to go through the entire loop. If there's ever a house that has a distance that is more than 50, we're going to return false. Because if there's a single one that we find that has a distance greater than 50, return false, because that means it's not a very safe street. So I less than lots.length. I plus plus. Remember, there's a possibility of null houses. So we need to say if lots bracket I does not equal null. We need to make sure that we do that. Then I'm going to say if. Now, I'm not going to just say return distance greater than 50 or something like that, because I don't want to return here unless it's false. So if, or unless it's, I'm returning false. Lots bracket I dot get distance. Is it get distance from hydrant? From hydrant. Remember, I didn't write that method. They wrote it, but I have to use it. If lots bracket I dot get distance from hydrant is greater than 50, then we need to return false, because we have found a home. We have found a home that is not close enough to the fire hydrant. They need to all be close. Now, when do I get to return true? You don't say so many students lose so many points. As soon as you do this, you lose basically all the credit on this for this problem. You cannot do that, because that would be returning true as if the entire house is safe and all you did was check the first house. You got to wait. You got to wait till you've checked every single one of them. If we get down to line 24, that means I went through this entire loop here that's in purple, and I never returned because I never found a house with a distance greater than 50. Now I can say return true. Very important. Don't early return. Okay, well, I think we have, let's see here, one more method to do. We get to return the number of two-story houses on the street. This is a nice little easy method to end with. So we have a method in the house class called get number of stories. So all we need to do is use the method get number of stories that belongs to the house to see if we can figure out how many two-story houses there are. I think this would be a good time for you to pause this and do it yourself. So go ahead and write this code for yourself on a piece of paper like you would on the AP exam, just or on a simple code editor. Don't worry about errors or anything like that. Use the method get. Remember, we're using in the house class, we have get number of stories, which returns the number of stories of houses. And we're looking for the number of houses that are two-story. All right, let's see how you did. I'm just going to erase these methods right quick. So public int get number of to story, I think was what it was called, or something close to it. I don't really care. I'm going to loop through the entire lots array. And we're going to check if it's null. So only if it does not equal null can we do something. Oh, you know what I just realized? I forgot to make a variable to count with. We're counting the number of two-story homes, so we need to start with a variable to count with. So how about num? We start with 0. All right, then what I'm going to say is if lots bracket I dot get number of stories. I forget what it's called. I said it 3 times and I can't remember. Get number of stories equals 2. Then we're going to say num plus plus, or plus equals 1, whatever you want to do. Wait till we loop through the entire array, then we can return num. Can we make this condensed? Well, we can, because we can actually use that short circuit nature. We could add a and. Since we're doing one right after another, we could just do it like this. And because I put lots bracket I not equal null first, we know that we have no risk of there being a null pointer error, which would break our program, because we check it first. And if this was false, because lots I was null, it would not execute this, which would not give us the null pointer exception. Yes, I know you can't find it because it's not written. All right. That is the story about using an arrays with objects. So I hope you got something out of that. I'll see you next time. Oh, I can't compile. What am I doing? All right. Take care.